Here's an interesting problem. The question asks us to find the equation of a sine function that has this following graph. And it looks a little strange right here. I don't know if everything's evenly spaced, but it's pretty well evenly spaced. So I'm just going to go with the numbers that we have right here. So what are we asking to do? In this function, we are looking to find a sine equation, a sine equation that reflects this graph. So what we always do is we start with this model. Our model goes y is equal to a times the sine of some quantity bx plus c. And actually, you know what? I always think of this as bx minus c personally because it just helps me to see what's going on. So bx minus c. All right. What could we say about this model? Well, I'll tell you one thing that I like to do right off the bat is this. I rewrite it. Y would equal a times the sine of some quantity b times x minus c over b. And you might recognize that number minus c over b. That is the phase shift. Okay? And that's a nice thing because you recall that when we were looking for values for b, well, our period was always found as 2 pi divided by this number b. So that's going to help us find this particular function's period. And of course, a was a number that was associated with our amplitude. And so we can actually just fill in the values based on what we know from our graph. So it's a nice thing that these are written in alphabetical order. There's a reason that they use these letters A, B, and C. They are convenient. So let's try a little bit of convenience right here. What is our amplitude? Well, a, in this case, if we're going with a sine function, looks like it goes as high as 4 and as low as negative 4. So we're going to make a equal to 4. Now, if I follow off by starting at negative pi over 6 and follow this sine function, it doesn't look like there's a reflection in the way that this is written. So we're going to say that there's no reflection right here. So we're just going to go with positive 4 in our model. And so I'm going to start writing my model over here. Y is equal to 4 sine of something. And so we need to figure out what goes there. Period. Well, the period, that's the next thing. How do we find the period? The way we find the period of any one of these trigonometric functions is we look from our ending point to our starting point, and we see how long that takes us. And the best way to find that period is to take your endpoint value, which is 2 pi over 3, that's our ending key point, and subtract from it that beginning key point. So in this case, that's negative pi over 6. Whatever the value is, right, we subtract that out. Well, this is going to give us 2 pi over 3 added to pi over 6. But we have to get that common denominator of 6 right here to make this work. Of course, pi over 6 is our second number. This is going to become 4 pi over 6. And so it looks like our period right here is going to be 5 pi over 6. All right, well, we've got the period. The question is, how do we get that actual value of b? Well, now, we're almost there, right? We would say that 2 pi divided by whatever value b is will be equal to 5 times pi over 6. But we're going to have to do a little bit of a cross multiplication right here. I usually treat it this way. 12 times pi, if I multiply both sides by 6, is equal to 5 pi times b. Right? If we multiply by the least common denominator of 6b, that's what we get. Then divide both sides by 5 pi, we get 12/5 is equal to b. So I'm using this second form of the model right here, so I'm just going to say 4 times the sine of, we have so far 12/5 times something, and it's going to be x minus something. Well, x minus, what is our beginning point right here? It's negative pi over 6. So we're going to subtract from that negative pi over 6. This very last number in this form is always the phase shift. And then what I'm going to do is I'm going to go ahead and I'm going to multiply this in so that it fits that first form of the model up here. This is what I really want. So doing that, I get y is equal to 4 times the sine of, and in parentheses, we're going to take 12/5 times x, and minus a negative, that's plus, let's see, 12/5 times pi over 6. The 6 and the 12 go, so we're left with 2 pi over 5. So our model, the function that we have right here, our sine function, could be said to be y equals 4 sine 12/5 x plus 2 pi over 5. Well, that's what we were looking for, and so we're done with this one. More to come.